Hey everyone, it's been a bit, so welcome back. This is 7.3. Um, I had 7.1 and 7.2 up a little later than I wanted, and again, this one's still a little bit late, but hopefully you can catch up. Rational expressions, basically fractions with not just regular fractions. They're not too bad, I promise. So we did a little bit of factoring review, and I'll just let you write this down. If you need more factoring review, go to the very, very beginning of this playlist and watch those videos in more detail. But for the sake of length on this video, we're going to keep going. So here's how it is. We're going to be starting with something like this, and I kind of showed them this was out of the book. We're going to factor the top, and we're going to factor the bottom, which is what they did here. The top factored out, the bottom factored out. And we're going to be able to cancel something. If you don't cancel anything, I mean, I guess it's technically possible, but we're going to probably cancel something every time. Factor the top, factor the bottom, and then we're going to say this is what we're left over with, which is our answer here. But this right here, this comes from what we eliminated, what we canceled out. Because here, obviously, x can't be 2 because 2 minus 2 is 0. But x can be negative 2 according to this. However, according to our original problem, just because that canceled out, that's only if x does not make this part 0, because it can't happen. So you take what you canceled out, set it equal to 0 and solve, and say, look, x cannot equal this negative 2. Obviously, x can't equal 2. We don't have to write that, but we have to say you can have this graph match this graph as long as x never equals negative 2 and x never equals, obviously, positive 2. So that's all we do is we factor the top, factor the bottom. This bottom became a difference of squares. Factor, cancel out. This is what we had left over, but because x plus 3 can't equal 0, then x can't equal negative 3. So like when we did this here in red, I said, look, what can't x be? Well, x can't be negative 3 because of this and positive 3 because of this. That's what we wrote over here. So just because we canceled this out doesn't mean all of a sudden we can use negative 3. Like it's still there, still in our original problem. We're just simplifying. So factor the top, factor the bottom, cancel out. Whatever got canceled, you have to say, hey, you still cannot use this. Because the graph kind of looks like this. It'll look the same, but you have this little hole in the graph where it's like, look, x can't be 3. So when you zoom in super, super far, negative 3 doesn't work. Negative 3.1 or negative 2.9, those work, but negative 3 exactly won't. So we just did more of this, and you can see like on number 3, and I'll just let you write this down because it was more in the same. Factor and cancel, and factor and cancel, and factor and cancel, and that's all it was. This was already factored and simplified. It says if possible. It's very possible for you to factor the top and bottom and go, look, nothing crosses out. Double check just to make sure you didn't do anything wrong, but it is possible that they'll give you one. So that led us to multiplying fractions. Now, multiplying fractions are pretty easy. When you have fraction times fraction, you just multiply the top two and multiply the bottom two. And then, yeah, so in our case, we're just going to shove everything together and then cancel out. So 8 times 7 is 56, and 2 times 4 is 8. Shove off. Well, I mean, you can kind of see like what we canceled out, the same stuff they canceled out. Like 2 times 4 is 8. Like technically we would have factored all the way out, and so we just said, look, we got 3 groups of 2's, we have an x, and we have what, 3 y's that we can cancel from each one. And then very similarly, if we cancel out x, just because x is potentially gone, we have to make sure we say, hey, x can't be 0. Oh, and we canceled out some y's, just so you know, y can't be 0. So we actually canceled out everything on bottom. Do we have to write 8 can't be 0? No, because 8 can't be 0 already. So I just said, look, let's just factor everything out. So that was 3 times 2. That was 3 times 3. We had these 7 x's and 3 y's. 3 times 2. So I was like, look, we can cancel. We can cancel. We cancel out an x, x can't be 0, cancel out at least one y, y can't be 0. 9 x to the 6 over y to the first power when everything cancels out. When it's something like this, and you factor yellow factored to yellow, green factored to green, blue factored to blue, once you do that, you look for stuff to cancel. The problem is we had this right here. Let me show you this right here. Because down here you can see this x minus 1 cancels with another x minus 1. We don't have another x minus 1. And we kind of do. So that's why I came over here. Look, 1 minus x and negative x plus 1 are the same. Well, if I factor out a negative 1, because if I distribute in, I get here. If I factor out negative 1, I do get x minus 1, which is where this guy came in. So I have an arrow here. This is where this negative 1 came from. Factor out a negative 1. That then matches. And then, oh, look, 3x and 3x match. And look, we have a negative 1 times x minus 4. And that was it. So you distribute that, and you get your answer. Then x can't be 0 because of this, and x can't be positive 1 because of this, or negative 5 because of this. So we just, did I do the exact same one? Yeah. So yeah, I just did a little more factoring and said, hey, 1 minus x is the same as negative 1 times x minus 1. So it's the same thing. Multiply, this is so confusing. Multiply is easy. Divide is easy too, because you take this second fraction and you flip it, and then you are no longer dividing, you are multiplying, and then it's a times d on top and b times c. So all we had to do was here, oh, that's still some more practice. Is that slightly out of order? Anyway, factor, that's already factored, factor, cancel out, distribute if there's something left. This 2 and this 2 cancel. This x and one of these x's cancel. But just because this says 2x and that says 2x squared, the 2 and the x are like separate. They're together but separate, if that makes sense. So make sure you factor correctly. Oh, this was a preview into the next video. How this is what we're doing today. The next part, we just flip the second fraction and do this. So there's 7.3 part 1.